Okay, we're on part 4, and I've taken this little example, x squared plus 5x plus 6 is equal to x plus 2 times x plus 3, a fact from your early days of factoring polynomials, and it's my favorite factorable polynomial. It just seems just so friendly, and I like to use it whenever I'm working on anything more complex because it allows us to focus on the more complex pieces and not how that got factored. So that's a fact that I'm sure you can grant me. I've changed that, that's that opening line, okay? I've changed that into a division statement, knowing what I know from grade 4 division, that I can take one of the factors, divide it into the dividend, and get a quotient, and it will be one of the other factors. So that's nice. We know that x squared plus 5x plus 6 is perfectly factorable, and that x plus 2 is indeed a factor. And then I'm going to just practice my division because that's a good thing to do. I know that that divides in and gets x, which gets me x squared plus 2x. And then underneath that I will subtract, get 3x plus 6 when I bring down the 6, which reminds me that I need to multiply by plus 3. And I can see already that I have 3x plus 6 when I multiply that through, and a remainder of 0. Okay, just a little reminder of what we already know, and I'm really writing tiny, but I guess I can squish that up a little bit. I think I have the skills even in real time here. Let's see. Whoa, that was too weird. Now you don't think I have skills, do you? How is this going to work? There we go. There we go. There's the division, and I'll move it over there. Okay, so now right here I have this nice statement, little bit, you know, bumping it up a bit. We're no longer just dealing with a trinomial expression. We're dealing with a polynomial function, a quadratic function now. And now I'm going to go back into remainder theorem and factor theorem kind of language, and I'm going to throw -2 into my function and see what happens with that. Now, I'm throwing that in there because if I look up, I've kind of hid something up here. I hid this little piece, didn't really hide it, but there it's sitting there reminding us. There's our x minus a. You may remember x minus a is sometimes how the divisor is referred to when you're reading about your polynomial division and your remainder theorem. Okay, so I'm taking that -2, because really right there, this +2 is a -2 if we think about it as an x minus a. So it's x minus -2, getting us that +2. So there's my +2. What's going to happen with that? So let's just do a little bit of that arithmetic here. I get -2 squared, and I get +5 times -2, and I get +6, which is +4 minus 10 and +6, that's 0, which is pretty cool because well, because it kind of relates to what we know about the factor theorem and the remainder theorem. When we divide by a polynomial by a divisor is 0, then we know something about two items. We know that it's a factor, and we know that if you plug a, I'm going to point back up to what we mean by a, into the function, we are going to get a 0 in terms of a result. The function evaluated at a will be 0. Why is that? Why does this happen? And why does the remainder happen even? Well, we're going to talk about the remainder in a sec, the next slide or the next video. But here in terms of a 0 remainder, it happens if you think about this is the versions of the of division statements, isn't it? There's our parfait is equal to Dairy Queen times queen is a 0, isn't it? And if I were to put that -2 in here instead of here, this is the same, remember. If I put it here, -2, I will get -2 plus 2. And that, my friends, dies a weary and dreadful death. It dies a death, becomes 0 times anything. This could be anything. It could be 10 million. And this will still multiply to 0. So when you have this beautiful situation of a factor, two things multiplying, when something pops in here and makes this nothing, and there's nothing to add on to the end, no remainder, you have proof that this is a factor. A remainder of 0 proves that this is a factor, and there's another piece of it where subbing in works. Okay, my time is up. Bye.